एडमिट कर दो। Good morning, all of you. Both the sections to join. After knowing the electrostatic potential concept, we will develop and we will utilize the meaning of the potential yes, you will all try to note down the top. Today's topic is electric potential. Electric potential, electric potential yes, electric potential due to an electric dipole, due to an electric dipole, electric potential due to an electric dipole electric dipole total 15 electric dipole at a point mute all कर दो. Electric dipole at a point on the axial line this is the topic today. You will note down this topic and try to understand how potential is calculated, and you make the habit to write down what I am writing here also. This is very clear and simple way to understand. Don't take it lightly. You just take it seriously. When we are saying about the dipole, we have already studied about the dipole. And now how potential is calculated in the case of the dipole. Suppose that at any one point where minus charge is here and we just drawn a dipole having positive charge. Yes, a system of minus and plus charge, point charge separated by certain distance. Suppose we are thinking of length of the dipole as 2a. Okay. If 2a is the length and you make a midpoint here and draw an axial line in the direction of x-axis. Yes. This is the direction along positive x-axis. Okay. How to decide? Where to decide the field lines? You think of any one point P. You think of any one point P from the midpoint of the dipole. Yes. And you think of here as x distance of the point P. Because axial line, we have taken O2P as x. And give the point of the positive charge, the distance of the point P, distance of the point P from the positive charge, what will be here? So if your dipole is here, AB, you can easily find the value of the AP and BP. BP will be what? X minus A. This is the distance of the point P from the B point. You can show it in the diagram. And from the point A, we can also draw the distance. Think of from this very point A, how to write x is added to half of the dipole length A. So this is now the distance of the point P from the A point. So if you are saying AB is the dipole, right here AB, which is equal to 2A. This is the length of the dipole, already known to everyone. And O to A is equal to O to B will be half of the length of the dipole. This is the assumptions, situations due to the dipole. If you are taking dipole, there must be dipole moment P vector acting from minus charge to plus charge. If the dipole is here and at the point P, what happens due to the plus charge and minus charge? At the point P, if you are thinking that test charge is Q naught, Q naught is the test charge. Q naught is the test charge. Now, if this very test charge is moved from one point to other point, suppose that this very charge is moved from any new point, A dash to B dash, any new name. In between, the test charge has been moved from A to B by very small distance dx. Think of if any test charge is at any one point P and you have to move this charge against the direction of the field, the positive charge move away, all the field lines are going away. Negative charge approaches the field towards it. So at the point P, the field will act, this is E positive, away from the dipole, and minus field will act, due to negative charge. So two fields are acting, but our purpose is to find the potential. So try to write the formula of the potential due to any one charge. So stepwise, you just mention A to P will be what? It is x plus A. B to P, it will be x minus A. This is the location of the point P. and O2 P is already taken X. These are all things are assumption made in the diagram. After knowing these all things, we will calculate the electric field. How to write the electric field? And electric potential. Electric potential at P point due to positive charge we are going to calculate first is given by. Now suppose we are writing this as V1, first potential. And we know the formula of the potential. We have derived today 1 upon 4 pi epsilon naught, the charge positive, divided by the distance of the positive charge to the point P, that is B to P. What is the value of BP here? 1 upon 4 pi epsilon naught times positive charge, and OP is here. OP is here. BP is here what? X minus A. Right, X minus A. You take it as equation 1. This is our first step to calculate the potential of the dipole due to the first positive charge. V1, 1 upon 4 pi epsilon naught, positive charge upon X minus A. Now similarly, we will write the electric potential. We will write the electric potential due to negative charge. Write the electric potential. Write electric potential at the same point P. At the same point P, but due to minus charge of the dipole. It is written as V2. For simplicity, we have taken here two kinds of potential. One due to the positive charge V1, another due to negative charge V2. So how to write the V2? It is similarly written 1 upon 4 pi epsilon naught minus charge divided by distance of the negative charge to the point P. It is AP. So that we can finally write 1 upon 4 pi epsilon naught negative charge upon X plus A. And this is your equation 2. So if dipole is here, we have two kind of opposite charges separated by very small distance. And we have to write the potential due to one kind of charge and due to the other kind of charge, so that we get the two kind of potential here, V1 and V2. We will apply the superposition principle of the potential. Now come to the next page. Write the total potential. Electric potential at P due to the dipole. Due to the dipole is, write common V, but this V is not individual. It is the sum of all the potential. Dipole has two kind of charges, so there should be two potential, and both are added together. And by putting the values of V1 and V2, we can once again write 1 upon 4 pi. V1 is due to positive charge, but the distance is X minus A plus 1 upon 4 pi epsilon naught negative charge. Take care of, during writing the potential, sign of the charge must be taken care of. X plus A Yes, this is our total calculation of the potential. You may take common factor outside the bracket to simplify the equation. If you are writing 1 upon 4 pi epsilon naught, charge is common here. You write only Q and remaining terms 1 upon x minus a, negative sign of the charge, 1 upon x plus a. Now simplify. You have to simplify this. 1 upon 4 pi epsilon naught, Q is the charge. Inside the bracket, on solving, we can write x square minus a square. And we will write x plus a minus x minus a. Yes. The solution will 1 upon 4 pi epsilon naught charge time. Yes. X plus a, write first, minus x plus a upon x square minus a square. Cancel out the term. What you have got here, very important lines you are getting. 1 upon 4 pi epsilon naught. You have the charge and you have a plus a, 2a. You have one new term. In the case of the electric dipole, dipole moment is also here. Dipole moment is also here. This is your step 3. This is your step 3. An electric dipole moment, the very remarkable terminology utilized in the dipole. Electric dipole moment. It is P vector and it is the magnitude of either charge with the length of the dipole. Yes. Give them remarks to the point electric dipole moment of any dipole. It is the product of the magnitude of either charge of the dipole and the length of the dipole. You make use of the P vectors in place of Q times 2A. Using 2 and 3, you can easily write. You can easily write in the next step, you will get the relation by making use of equation 3 and 4. V is equal to 1 upon 4 pi epsilon naught P vector, a total magnitude of the P you can write. And here x square minus a square. This is your final formula. In the case of electric potential due to the dipole at any point on the axial line, this is your required formula. This is your required formula for electric potential. On the axial line. Of an electric dipole. So V axial, for memory purpose, you can think of V is the common term, but this answer is for axial. Now, if special cases arises, in this very discussion, what you will do now? For very short dipole, A very short dipole is written anywhere in the paragraph in the discussion of the electric dipole during calculation of electric potential. You just think X, the point P from the midpoint of the dipole is much more far away in comparison to the half of the length of the dipole. If X is much more greater than the small a, what happens then? A square in the equation 5 is neglected. If you are neglecting, you can write the potential at P point on the axial line as 1 upon 4 pi epsilon naught times the P and x square only. No other term. A square is neglected. So, if short dipole is pronounced anywhere in the case of discussion of the electric dipole and finding the potential, we can easily write P by x square and we write the equation as 6. So this is the discussion of how to calculate the electric potential. You can revise here. You can once again visualize number 1 page. Yes. Dipole AB. Length of the dipole is 2A. Half of the dipole is OA and OB, which is each value is having A. Q naught is the test charge. Any other charge due to the charge given on the dipole, which experiences field and force, and due to which whenever this very test charge is brought from any one point A dash to B dash by a distance dx, the total amount of work done in bringing the test charge from A dash point to B dash point to decide the potential at any point on the axial line. That point must be within the field of the charge of the dipole. If you are thinking of positive charge, take care where you are locating the positive charge. Most of the students used to write in the reverse order and thinking they are independently writing the answer. But that is not so good. If you are changing the position of the charge, you are all deciding opposite direction due to alteration of the position of the charge. For simplicity to understand and to come in the common sense, if you are putting the negative charge at the A point, the field will be attracted towards. And if you are putting positive charge to the A point, then dipole will reverse their order. Field will reverse their order. So it is better to show the field away from the system. V1 Q by x minus A. Equation 2, V2 1 upon 4 pi epsilon naught minus Q by x plus A. Similarly, by utilizing the principle of superposition, by writing superposition principle, V1 plus V2, and putting all these values, taking common Q, taking common factors 1 upon 4 pi epsilon naught outside, we are making the use of the 1 upon 4 pi epsilon naught. This has certain values, which is 9 into 10 to the power 9. So charge may be given, but the common factors K, where we have written 1 upon 4 pi epsilon naught, if taken outside, an on simplification of the algebraic terms inside the bracket, we get Q times 2A, and we make use of the meaning of the electric dipole moment. q times 2a, so that we may write their electric dipole moment. So how potential is related with the dipole moment as well as the length of the dipole. So ultimately we get the formula V is equal to P by x square minus a square. And if due to any cause, if short dipole is given in the question, you make the step of x much more greater than the small a, so that the small dipole and the half of the small dipole, their length is neglected, and we easily write P by x square. This is the discussion for axial potential calculation due to the dipole. Now come to the point. Next step. Another topic related with the electric potential. Get ready for another discussion, but related with the electric potential. Make patience. We are once again writing one new, very much important questions. In so many exams, this has been asked already for very short type of questions. Long question, short question, kind 1, and short question, kind 2. So such questions are arise in conceptual development. Formulas are utilized during solving the objective question and numericals. Now write the topic. This is the, yes, short question, but very important. Electric potential, electric potential at a point where due to an electric dipole on the equatorial line equatorial line. Yes, try to understand the situation. We have only 10 minutes. You just draw the diagram for, you think of negative charge body at a, take a dipole, write another body, minus charge, yes, plus charge. You write one negative, other positive. At B, you take midpoint O, you write the length of the dipole as 2a, as it is already discussed. Draw the perpendicular line. Draw the perpendicular line with the dotted lines is drawn to the midpoint of the dipole. Yes, very nice. Just coincide with the O. You write y-axis here. Take any one point P where we have to calculate the potential at P. Join the A point to the P point. Similarly, join the point B. Yes. If you are thinking of positive charge first, you write R1. If you are thinking negative charge later on, write R2. But where is the point P? It is at a distance R from the midpoint of the dipole. This very OY is called equatorial line. OY is called equatorial line. and you can now easily calculate A and A. And just write the formula for electric potential V1 1 upon 4 pi epsilon naught. Your charge is positive. It is at a distance R1. Take it as equation 1. Similarly, write the electric potential at P 1 upon 4 pi epsilon naught. Your charge is minus, but it is at a distance R2. Okay. And put the total potential by V1 and V2. Right here, by putting 1 and 2, 1 upon 4 pi epsilon naught, positive charge at a distance R1, and 1 upon 4 pi epsilon naught, negative charge with the distance R2. Take the common term, 1 upon 4 pi epsilon naught. If you are writing charge common, you may write 1 upon R1 minus 1 upon R2. But here, in the case of the equatorial line, this the region is here, A to P, distance is equal to B to P. So what you have decided, the AP distance as R2 and BP distance as R1. So you will get you write any one common R here, if necessary, or you write R1 is equal to R2 directly. And then we will get R1 minus R2. This will be 0. This will be 0. And whole formula becomes 0. This is your required answer for the situations of finding the equatorial line, the potential at any point on the equatorial line. This is our purpose. Okay. Any problem? If you have, you may unmute and you may ask, you may say, we have very few seconds of time to finish our class. Bolo. Anybody may ask. ध्यान है ना पढ़ाई पे? Okay, thank you.